Just wanted to also go over some more multiple step heat problems, and we're going to be calculating heat in multiple steps here on homework 15. Okay, so let me show you homework 15. We have these problems here. They focus only on water. Okay, so you're going to be using these constants. I know that the C value for ice is a little different than what it is on your other list, but I went ahead and used the 2.1 since it's here. The heat constant for freezing and condensing water is a little different, 334 versus 333. So I'm going to use those numbers for this assignment here. Okay, so as you look at this, the first question, it says you have a 150 gram sample. It starts at 0 degrees and it's going to be melting first, and then it's going to be warming up to 25 degrees. So you can actually see a graph here, a visual graph of the temperature going up in the graph. It's starting at 0 degrees. It goes through the phase change when it with ice, and then it warms up to 25 degrees. So what's going to happen here is you're going to have two steps. You're going to have step 1, where you take the 150 times it by the constant to melt ice, which is 334. And then you're going to have the next step where you're going to take the mass, the temperature change, and the constant. So it's MC delta T here. And you're going to take these two answers and then you're going to add both of them together. Okay, so work on this part. You're going to be doing the math to melt the ice, which is right here, 150 times 334, and then the math, the MC delta T for the warming up from 0 to 25 degrees. Okay, this is a two-step problem here. We go on to the next question, and it says, suppose the IC hot lab, the burner transferred 325 kilojoules. That's the same as saying 325,000 joules. So that's the joules you're using, okay? And you wanted to know if that amount of energy can take 450 grams of liquid water up to 20 degrees Celsius. So what we're doing is we're going to start at 20 degrees Celsius, and we want to know if we can boil it away. Okay, so we're going to warm up 20 degree water up to 100, and that's going to be an MC delta T problem because you're changing temperature. And then you're going to be doing 100 degrees water and seeing how many grams we can boil. Okay, so that's going to take a little bit more steps. I'm going to show you here in a minute, but it's going to be one step going from 20 to 100, and that's going to equal 80, because it's 80 degrees between those two numbers, and then 4.184 and timesing it by 450. Okay, and then we're going to be looking at the 450 grams timesing it by 2600, because that's the heat constant to vaporize water. Now we want to know, is these two numbers going to be enough to do the whole thing? And then if not, then how many grams would it be if it's less than that amount? So let's look at it in a little bit more detail here. Still on number 2 on this problem, okay? So we only have 325,000 joules. So what you want to do is you want to have to subtract the number of joules to warm up the water from the 325, and then take the leftover joules here, and then dividing it by the heat of vaporization. And what that's going to do, it's going to actually tell you the mass, how much mass of water. So if you put it all together in an algebra equation, then you have the 325,000, that's what they were given. The math it took to warm up the water, okay, that's going to be the number for, let me write this out here. It's going to be the number for 80 timesing it by the 4184, and then timesing it by the 450. Okay, this part here, excuse me for moving the paper around here, but this is the step to take the 80 degree change in temperature, the 4.184, and the mass of 450. All this multiplied together is equal to this number, 150,000. So 150,000 of the joules is taken to warm up the water, and then you're going to add that to the 2260, and you're going to times it by X. This is going to tell you the amount of grams that can boil, because it has to add up to 325,000. These two added together, if all 450 was doing the math, if you did all 450 grams, it would not equal this. This would be much more. This side would be much more if this was 450. But it's going to have to be less than 450, but you don't know what that number is. And that's what you're looking for the answer for number 2, is this X. So set this up. This is the part to warm it up. This is the amount of heat they give you in the problem. How much of the mass of water can you multiply by 2260 to make them equal to 325? Okay? Calculate that out and solve for that X for number 2. Okay. Let's go on down to number 3 after you've worked those two out. Okay? Let me move the paper up here for you. And this problem is a can of ice, a can of soft drink. It's got 340 grams, and we want to place it from 25 degrees Celsius, that would be like on the room temperature. We want to put it into the freezer and take it all the way down to -12. Okay? They're asking how much energy must be removed. So you're cooling it down. That means you're going to be a negative joules of final answer, negative value. Okay? So let's look at this visually. Okay? You're going to put into the freezer from 25 degrees, and it's going to go down to -12. You're asking for the number of joules that are lost. So step 1 is going to be the M340 times MC, and then the delta T is going to be -25 because you're cooling it down. Your 25 degrees is going to be minus because you're going from your T final 0, your T initial is 25, so you subtract the 2, you're going to get -25. Okay, that's step 1. Then step 2, you're going to go from 0 degrees liquid pop to 0 degrees frozen pop, and that's basically water. You're going to use the same constants for water. So you're going to take 340 times it by -334 joules and multiply those two together. Okay, these multiplying steps for step 1 and the multiplying step for step 2 and this final step for step 3, you're going to do each one individually, and then you're going to add them together. And that's going to give you your final answer for the problem. But you first do the change in temperature problem here. Then you're going to be doing the freezing step here. Okay, and then you're going to cool down from 0 to -12 here, and that's going to be a different constant. Every time we do ice, every time we do steam, the numbers at the top, and I don't think any of these problems deal with steam on this particular paper, but if it was, you're going to use this constant for this is for solid water, okay, and then this number is for liquid water. The C values are different. Okay, so going back down to 3 here, we're going to do the temperature change to cool it down, then we're going to do the temperature change to freeze, and then we're going to do the temperature change, you're going to do a phase change to freeze, and then you're going to be, hold on a second here, I'm going to change. And then we're going to be going down here. Sorry for that delay with my computer. We're going to go 0 to -12 here. Okay, 0 to -12. And that's going to be the constant for ice. 340 is the mass, and the change in temperature is -12. Okay, because you're going from 0 to -12, the difference is -12 because you have to take -12 minus 0, which is the same as -12. So again, all these numbers are going to be a minus number. And your value, I believe, in the answer key, I'm looking for it here, guys. Your answer here is going to be, you have to look at the actual, check out the answer key value. I didn't have that out here while I'm working, but there is going to be a final answer on the visual that I gave for, I emailed that out last night on Remind. So add these 3 together, add these 3 values together to get your final answer for number 3. Okay, let's go over and move it over to 4. Okay, so number 4 up here. The question's saying that you have 65 kilojoules of energy is added to 150 grams of ice, and you're asking what is the final temperature of the water. Okay, so we're at this little graph here. Sorry, here I'm trying to move the visual. I'm working upside down as I record here. So 0 degrees, I'm going to be melting it, and then I'm going to be warming up, but I don't know what the final temperature is going to be. The X degrees Celsius, what I don't know. So let's set it out like an algebra equation, okay? So we have the 65,000, which is 65 kilojoules, 65,000 joules. Set it equal to the amount of energy it takes to freeze the water, or sorry, to melt. Excuse me, to melt. It's the energy to melt the ice. Okay, because we're starting out with 150 grams of ice, so we're going to take 150 grams of ice and times it by the constant for melting, which is 334, and that final value is going to be left there. And then you're going to plus it with the other part to warm it up, and that's going to be 150 times a C value for water, which is 4.184, and then we're going to do TF minus 0, which is the same as just TF. And so TF is what you're solving for. That's your X. So you have a number here, a number here. When you multiply it out, and then you're going to multiply these two together, and that's going to be beside X. And then you're going to do your algebra. Get these two guys together by bringing this over here by subtracting, and then this value divided by these two multiplied together to get your algebra. So set that up and solve for your answer. Okay. Now the next question is involving 250 kilojoules, which is the same as 250,000 joules. Okay. And what we're doing is taking 60-degree water, and we're trying to take it and see if we can completely freeze it. Will this 250,000 joules be enough to freeze 400 grams? That's 400 grams of water. Okay, so we have two steps. We're going to take the 60 degrees down to 0, and we're going to take 400 times 4.184 times 60. Okay, and then those three added together, multiply together. You're going to take that, and then the second step is 450 times 333, and we want to take these two values, this multiplied together, add them together, and see if these two added together is below 250. If it's not, then you have to basically say yes or no. You don't really have to figure out the amount that did freeze, but you could, obviously, if you wanted to. Okay? Now, the next question talks about an ice cube in a whole tray, which is 235 grams of ice. You're at -7. You want to warm it up to room temperature and get it all the way to 22. It just basically wants to know how much energy must be absorbed. That means you're going to have a positive energy, a positive joule number here by the contents of the tray in order to get this to happen. So we're going to warm up ice and to see how much energy it takes. So this is going to be actually 3 steps. Okay, 3 steps. And you're going to start with -7 to 0. The change in temperature is 7. Timesing it by the constant, timesing it by 235. Multiply those out, get a number. And then we're going to add that together with 235 times 334. We're going to multiply these together and then put that number here. We're going to eventually add all 3 numbers together. And then we're going to take 235, timesing it by 22, timesing it by 4.184, and we're going to get that value there. And then these 3 values are going to be added together. Okay? And that's going to be your answer. Now this final answer actually is 76 actually. The reason why I need to know that number is because 103,576 is because you're going to take that value, take that heat, and take it down to the very last question. Okay, excuse me on this movement here, trying to work upside down as I teach here, but take the value from number 6 and use it for number 7, which the answer is 103,576 joules. Okay, And what we're trying to do is this energy enough, can be removed from 40 grams of water steam, which is vapor, at 100 degrees? Would it be enough to get it to all condense? And then what would be the final temperature of the water if you added that 103,000 joules? Okay, so eventually what we're doing is taking 100 degree gas to 100 degree water, which is going to be liquid water here. We're going to take it from gas to liquid, and then we're going to take that liquid water all the way down to an X amount of temperature that we don't know. That's what we're solving for. Okay, so these two values can be added together. We're going to condense the water, and that's going to be 40 grams times 2,261. That is to condense it. And then we're going to take this change in temperature, but we don't know what that value is. Okay, right now we're going to make the change in temperature X, which makes math a lot easier. You don't have to have 100 minus T final, which is what you're eventually finding is T final. But let's just do that separately. So we're going to take the 40 times 4.184 times change in temperature, and that's going to be your X. You have the 103,000, you have all this multiplied together, and then you have 40 times 4.184 times X. Solve for this X, and then this value is going to be put here with 100, and take 100 minus the value you just solved for, and that will give you a T final. And I believe your answer is about, I believe it's about 22 to 23 degrees Celsius, I believe. Okay, that answer here. Okay, the other answers are going to be listed here. Let me find it really quick in my folder here. Anyways, your final answers, yeah, actually this is going to be, this last question is going to be around, this last question is going to be 21.2 degrees Celsius. Okay, the other answers up here and up here, I would look at the document that I sent you guys on the answers, but this format, go ahead and take some time to watch it over to see how to do all 7 problems. These 4 in the back, and then these 2, these 3 in the front. All 7 problems, okay? Again, email me if you're having any problems or questions, and I can talk you through any of these problems.